On the behalf of Government Engineering College Banswara, I Dr. Sunil Gadhwal welcomes you once again in video lecture classes. As we in previous class we had discussed about bomb calorimeter structure. Today we are going to discuss about how it is working. So as you can see in this diagram that a fixed weight of solid or liquid non-volatile fuel is taken in this platinum crucible, and a fine magnesium fuse wire which weight is noted is one end is tied with the electrodes and the other end is dipping in the fuel, and over the fuel a cotton thread which a weight is known or noted in notebook is also wrapped so that this magnesium fuel wire is in the fuel, and with the help of this valve oxygen we will introduce in the bomb calorimeter. Also a 10 ml of distilled water is added in the bomb calorimeter, and this bomb calorimeter is placed in a copper calorimeter where the quantity of water is fixed to absorb the liberated heat during the combustion of the fuel, and the initial temperature of this water before starting the experiment is noted with the Beckman thermometer. And also this calorimeter is having one electrical stirrer to make the uniform temperature of the calorimeter water. So as soon as we connect the electrodes with the 6-volt battery and we supply the power, so this fuse wire will spark, and this cotton thread will start burning, and because this cotton thread is covered, all the fuels are tightly covering all the surface of the fuel, so on combustion it will start the initiation of the fuel, and fuel will burn in the presence of oxygen. So what is the trapped sulfur and hydrogen will also on combustion will generate more energy, and this energy will increase the temperature of this bomb, and the pressure will goes up to 25 to 30 atmospheric pressure, and the liberated heat is absorbed by this water, and the temperature of this water will increase, which was measured by Beckman thermometer. So this is the working procedure of the bomb calorimeter. So now on how to calculate the amount of heat is liberated on the combustion of a unit mass of given sample. So let mass of the sample taken in crucible is x gram, the calorific value of fuel is L, which is higher calorific value. Specific heat of water we know is S, and the initial temperature of water before starting the experiment is T1 degree centigrade, and finally it reaches up to T2 degree centigrade. The mass of water sample taken in calorimeter is W gram, and the water equivalent of calorimeter, stirrer and thermometer is small w gram. This is small w is representing the temperature increased of or heat absorbed by stirrer, then this thermometer, then the bomb. So mass into specific heat of apparatus. The heat liberated by burning of a fuel is X into L. X is the quantity and L is the calorific value of fuel. So that this much heat the fuel will liberate, and this heat will absorbed by water, which we are taking in copper calorimeter. So the weight of water is W, specific heat of water is S, and the temperature difference T2 minus T1, because at the starting of experiment the temperature of water was T1 and it is up to T2 degrees, so temperature increase is T2 minus T1. This is the temperature difference. So multiplying, putting the values of this, we will get also the heat absorbed by the apparatus, which is W into S into T2 minus T1. The specific heat of water we know 1 calorie per gram per degree centigrade. So the total heat absorbed by the water or apparatus is W into 1 T2 minus T1 plus small w into 1 into T2 minus T1. So from here T2 minus T1 will come as a common, so W plus small w. So this is the total heat absorbed by the apparatus and water. So according to the principle of calorimeter, heat liberated by fuel is equal to heat absorbed by water plus apparatus. So putting the value here, so XL is equal to W plus small w into T2 minus T1. So HCV of fuel is equal to higher calorific value of fuel is equal to W plus W into T2 minus T1 upon X calorie per gram if units are in CGS system, and kilocalorie per kg if the units are taken in MKS system. So putting so let's H is the percentage of hydrogen present in a fuel. Then gram of hydrogen present in 1 gram of fuel is equal to 1 into H upon 100 gram. As all fuel contains some hydrogen, and on combustion of fuel this hydrogen converted into steam, vapor phase of water, and can be determined by experimentally according to, as we know that this is the hydrogen in the presence of oxygen. On combustion it will make steam. So if the weight of molecular weight of S is 2, here the molecular weight of S2 is 18. Suppose this is 1 gram, then it will give 9 gram of water. So 1 gram of hydrogen giving 9 gram of water. So the weight of water produced from 1 gram hydrogen is equal to 9 gram. Weight of water produced from H upon 100 gram hydrogen is 9 into H upon 100 gram. Weight of water produced from 1 gram fuel is equal to 9 H upon 100 into 9 into H upon 100 grams. So latent heat of water is equal to, as we know, that 587 calorie per gram. Putting the values here, we will get 9 upon 100 into H into 587. This is the latent heat. So LCV is equal to HCV minus latent heat of water. So here putting the values, it will come as HCV minus 0.09 H into 587 calorie per gram. So putting the values here, we will get the lower calorific value or higher calorific value of the fuel. So in the next class we will discuss the corrections of calorific value calculation by bomb calorimeter. Means what are the factors affecting the calorific value of fuel during the experiments. Hoping that you would understood the topic very well, and in next class we will discuss about the corrections. Thank you.